Hello and welcome to my lab walkthrough of the Configuring DHCP lab. In this lab, we're going to configure DHCP on our server here, and we're going to configure it for PC1, which is a device on its own internal network or its own broadcast domain. And then we're also going to look at what we have to do to allow DHCP to travel through a router. Remember, DHCP uses broadcast messages to find a server, but routers don't forward broadcasts. So we're going to have to do something in the router to tell the router to forward DHCP messages to this DHCP server. So let's go ahead and get started. So the first step we have to do is we have to configure our IP addresses on the router. Okay, so the first step I want to do is I want to enter privilege exec mode, so I'll type enable, and then from privilege exec I can go into global config mode. And for that is configure terminal. And actually, this is why it's sometimes better to not type the full word. If you can just type a few letters, Cisco will figure it out. So configure terminal, and then I got to go to interface gig 0/0/0, and gig 000's IP address is 192.168.1.1. And I will turn the interface on with the no shutdown command. Now to do interface gig 001, I got to go into interface gig 0/0/1, IP address 172.16.1.1, and no shutdown. So I've got my two interfaces configured. The next thing I want to do is take a look at just double checking it. So many times I've done it in industry, I've seen students do it. You type in all the commands and you just keep going through the lab. You get to the end of it, nothing works. So it's always best to double check everything before you move to the next step. Show interface gig 000. And I can look at this. Let me widen my screen out a little bit and look here, gigabit 000. This is important to look at. It is up and up. I'm connected to something. And this is my IP address. And I can even see some other things here like my bandwidth. And there's a lot of information here, but that's the key stuff for what we're looking at right now. Now I can do the same thing, show interface gig 001, and double check it. I did indeed get the right IP address, the right mask, and the bandwidth is 1 gigabit as well. So now the next step is let's verify our connectivity, and I'll show you how to do that. The command to verify connectivity is show CDP neighbors. This is a really great tool to get comfortable with, our command. And what this does is this gives me a table of all the Cisco devices that I'm connected to. If I'm not using Cisco devices, there's another protocol called LLDP that does the same thing, but that's not enabled by default on Cisco iOS devices. So what I have here is I have this table that says I'm connected to S1. The interface that the router is using to connect to S1 is gig 000 right there. And then it tells me that S1 is a 2960, and the port I'm connecting to on S1 is gig 01. And then I see the same information for S2, and this command also works on the switches too. So I could go into the switch and enable show CDP neighbors, and from S1's perspective, I'm only going to see the router. Let me scroll down and we can look at that output of the command. So S1 says my interface gig 01 is connected to a device named router, and its platform, it's an ISR 4300, and the port on the router I'm connected to is gig 000. So it's always good just to double check and make sure that you've completed the step properly before you move on. So now the next thing we have to do is we need to configure our scopes for the DHCP server. Let me think. I don't remember if we have the IP addresses here. Nope, we have to configure the IP address here before I skipped ahead to step 4. I almost forgot step 3. So I'll go over here into my desktop, go to the IP address field, and then I will put the IP address in here. And then my default gateway is, I'm sorry, 172.16, right? 172.16.1.1. And I've got that done. And then just for the heck of it, I'm going to ping. I want to make sure that my server can talk to my router. So I'm going to go ahead into the server and ping the router just to verify I have connectivity. Now the next step I'm going to do is I'm going to go ahead and configure the scope for that server. So to do that, I have to go to the Services tab, and then I'm going to go into DHCP. First thing I want to do is turn that service on. If I don't turn it on, then I can configure all the scopes I want, but they won't do anything. And then Packet Tracer behaves a little bit differently than I'd expected it to. You can't change this first server pool. This is the server pool that works for locally connected devices. So all I can do is create my pool right here, and my default gateway for devices connected on the same network as the server or within the same broadcast domain, they have to have that. I will give them a default gateway of 172.16.1.1. So any device that is in server pool is going to be told this is your default gateway. And then we're also going to tell our server to start allocating IP addresses at 192.168.111. So we're not going to assign any addresses from 1.1 to 1.10. We're going to reserve those for static IPs. And then we're going to tell it to do not allocate any more than 200 addresses. And I'll go ahead and save that. Now the next thing I want to do is create the pool for network B. And for network B, I can go ahead and change this. And network B is going to advertise a default gateway of 192.168.1.1 and 192.168. Oops, I can't use the button. I got to hit tab. 168.1.11. And that's correct. And then I got the 24-bit mask and the 200 maximum numbers of users. So I'll go ahead and click add. And it says I have the wrong gateway. Yeah, 192. I messed that up. So there we go. And let me add that again and double check it. Network B 192.168.1.1, and the start address is 111, and the mask is 24 bits, and maximum 200 users. So now I can go ahead and let's take a look at this from PC1. So PC1, if I go into I can go into my command prompt, and if I type ipconfig, I will see I have an IP address, an IPv4 address, but it's not a valid one. Not really. What this is this is a PIPA, remember, automatic private IP addressing. And if a device tries to get an address via DHCP and doesn't reach a server, it's just going to make one up beginning with 169.254 and a 16-bit mask. So what happened is we turned on our PC. It tried to get a DHCP address, and it didn't because our DHCP server wasn't yet configured. So what we can do is we can tell our client to re-request a DHCP. So the command for that is ipconfig with a / followed by renew. And now we did indeed get an address for our PC. Now let's go ahead and look at PC0 over here on the other network. So PC0 should be able to get an address, but it's not really because it's not going to get that broadcast through the router. We'll tell it to do it, and we'll give it a couple of seconds, and it should fail. And the reason it's going to fail is because PC0 is sending a broadcast to the router, and the routers do not forward broadcast. So to fix that, I have to go into the router, and I have to configure it to forward DHCP messages. And the way I do that, let's open this up a little bit so you can see everything, is I need to go into interface gig 000, and I have to use the command IP helper address, IP helper address 172.16.1.6. And what this does is it tells interface gig 000, if you get any broadcasts for DHCP services, this interface right here, you're going to go ahead and forward that as a unicast packet to the DHCP server. So once I turn that on, I should be able to go into PC0 and do ipconfig renew. And let's see what happens. And now we did indeed get an IP address from the DHCP server. So in this lab, we examined how to create a DHCP scope, and also we examined the purpose and use of the IP helper. So DHCP broadcasts can indeed be forwarded by routers to a DHCP server.